What's up, y'all? Bro Who Codes here, and today we're going to be solving the legendary two-sum problem on LeetCode. This is a great place to start if this is your first LeetCode problem, and it's pretty iconic and pretty popular, so let's get into it. Given an array of integer nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So basically what this problem is asking is to return the two indices of the numbers that add up to the target value that we have, right? That add up to 9 in this first example. The two indices that have values that add up to target are indices 0 and 1, right? Because at indices 0 and 1, we have values 2 and 7, which add up to 9. Now, as you can see in this last example, we have only two values, and those two values have the same number, right? Both these indices 0 and 1 have the same number, which is 3, and that's perfectly okay. They're two different values because they have two different indices. So we can make this pair. So as you can see in this example, 3 plus 3 equals 6. So the return value that you would return would be 0 and 1. The same thing with this middle example as well. The pair is actually 2 and 4. So it would return 1 and 2 because they're at indices 1 and 2. So let's go ahead and code this nested for loop approach. So firstly, we want to iterate over the entire array, and that'll be our first pointer, right? So we'll use a for loop for that. Our first pointer is going to be called I, and it's going to start at 0 and go until I is greater than or equal to num's length, which is basically this, but written in reverse. So we want to increment I every time, so we iterate through the array. And for each element that we point at with the first pointer, I, we also want to iterate over all the elements to the right of the first pointer. So to do that, we'll create a nested for loop. This will be the second pointer. We'll call this one j. This one will start at I plus 1, right? Because that's the first value after I. That's the index of the first value after I. And so in the same way, j is going to be less than nums.length because we can't go over the length of the array. And we're going to increment j every time to enter this loop. And now that we have pointers pointing at two different values, right? We have our two potential values that will add up to target. So we need to check if they actually add up to target. So we should use an if conditional here, right? If nums of I, right? If the value at index I in nums plus the value at index j in num equals target, then we find our answer. And we can just return an integer array with the indices of those two values. So we'll put I and j in any order. And yeah, that's basically it. If we exit this for loop and we don't find two values that add up to target, that means that there are no values that add up to target, no two values that add up to target. So we should return an empty array. And that's what we'll do right here. And yeah, that's basically it. So the time complexity of this approach is n squared, because not only do we iterate over every single element inside of nums, for each element inside of nums, we iterate over basically all the elements inside of nums again, right? The time complexity of this would be O of n, right? And the time complexity of this is basically going to be O of n minus 1, right? But it basically equals O of n, right? If you just remove the constants. And so if you multiply these together, then you get O of n squared. And that's the time complexity. The space complexity is constant, which is really good because we don't use any data structures to store any of the information that we're using in the problem. So it's constant. And that's about it. But there's a way to improve this time complexity. Let's go ahead and look at another approach. So a better approach to this problem is to use a hash table. So all a hash table is a data structure that stores key value pairs. That's it. The key can be anything, right? The key is the first thing, right? That could be a string, a character, an integer, a double, whatever. And the value, the thing that the key links to, could also be anything. It could be a string, an array, a list, anything you want. So we could use this to store information in the problem, right? And then access that information later so that we can make the problem more efficient. And you'll see how this will work in this problem as I go through it. So let's look through the values of the array, right? So we'll start at 2, right? We're looking at 2. And 2 is at index 0, right? The value that we would need to add to 2 to make it 9, right? The target value would be 7, right? But we haven't seen 7 yet, so we don't know that, right? We don't know if we have 7. So, but we do know that we have 2, and it's at index 0, right? So we can store that in the hash table. So we could store the key as the actual number in the array, right? So we could store the key to be 2, right? And then we can store the index of that number, right, to be the value. So it'd be 0, right, because 2 is at index 0. So we could keep going through the array, right, and doing the same thing. We'll look at 7, right? Okay, what value do we need to add to 7 to make it 9, right? It needs to be a 2, right? We need to have a 2, right? Oh, wait, have we seen a 2 before? Oh, wait, we have, right? Because it's in the hash table. So we look at the hash table, right? And we say, is there a key that is the number 2, right? The integer 2. It's like, oh, cool, there is, right? We found it. So what index is it at, right? Oh, it's at index 0. Cool. We saved that information so we could use it later in the problem. So we found our answer very quickly, right? We didn't have to do 2 for loops or 2 pointers or anything. We just used a hash table. So the answer we returned would be the value that we're currently at, which is 1, right? And the index of the value in the hash map, which is 0. Or you can reverse them if you want to have them in order, but the order doesn't matter. So let's see if we can code this better hash map approach or hash table. They're the same thing. So first we want to create the hash map, right? Obviously. And it's going to have integer key values and integer value values. And let's go ahead and initialize it. So the key, right, is going to be an integer, and the value is going to be an integer as well, just to clarify. So we want to iterate over all the values using a for loop and a pointer called I. And I has to be less than nums.length for us to enter this loop. And on each iteration, we want to increment I. And so what we want to check for every single time we loop through this for loop is if the second value that we're looking for is in the hash map, right? So how do we even know what the second value is, right? Well, we do what we did in the problem before, right? So if you look at this relation, right? We know that the number that we're looking at currently, which is nums of I, right? If we add it to the second value, which we don't know what it is, right? But if we know that if we add it to this second value, it will equal the target we're looking for, right? And if we move the values around in this equation, right, then we can actually figure out that the second value is going to be target minus the current value that we're looking at, right? So we can check the hash map for that key exactly. So what we would do here is if hash map contains key, and the key would be target minus nums of I, right? Then that means we found our second value, so we can return the answer. And so that would basically just be return new int, and we return the indices. So we return I, right, the value we're currently looking at, and the value, and then we return the indice, the index of the hash map value, right? So that's going to be hash map get, and we're going to pass the same thing in, which is going to be target minus nums of I, and that'll get the index that we stored for this value. And if this condition actually isn't true, then what we want to do is put the current value or the current number and its index into the hash map so we can access it later. So you're going to do hash map, right? HM put. We're going to put it into the hash map. We're going to put the actual number as the key, right? Nums of I. And its index as the value, right? And so by the end of this for loop, if we actually haven't returned a pair, right? If we haven't found the pair, then that means there is no pair. So we want to go ahead and return an empty array. And the time complexity of this problem is actually a lot better than the one that we just did. A time complexity of O of n, because we only iterate over the array once. So we actually take a little bit of a hit in the space complexity. Whereas the previous approach had a constant space complexity, this one has a linear one because we store n elements, right? Meaning the length of nums, right? The length of the array. We store at most n pairs into the hash map. So the hash map can be at most n pairs long. We have a time complexity and a space complexity that is linear. I'd say this is a lot more efficient than the other approach. It's more balanced. It all depends on what you're trying to optimize for. So that's basically it. Thank you for watching. I'm Bro Who Codes. I hope this helped, and I hope that you pass all your technical interviews with flying colors. I'll see you for the next video. Take care.